Hey guys, I got a late start. Well, I didn't get a late start. I've been looking at this stuff, a lot of stuff this morning. And since they took so long, I was able to pull up both of these for you. Here's the Go 16 East showing last night. There's the UTC. So at 4:30 UTC, which would make it around midnight last night, Eastern Daylight Time. You can see there's the planet still reflecting. I pulled it up for you. UTC versus Eastern Standard Time, that's 5 hours. And if you go UTC versus Eastern Daylight Time, which I had pulled up also, it's 4 hour difference. So since we're still on daylight time, I believe here, Eastern Daylight Time, that would have been a little after 11:15, showing up down there on the bottom of the globe on the eastern side. And then I pulled it up on this is current. This is the Himawari-8. That's on the other side of the planet, the weather satellite. And you can see it showing up here pretty much around the same time as usual, although I think it used to show some light at 1340 UTC. So it's moved that away a little bit, I would say, which that away would be towards towards Africa anyway, in that direction. You're still seeing more light reflecting off this planet on the Himawari satellite side, on the western side. You can see how it's all pixelated out. But when I first caught it back on the 17th, these pixels were up higher. I mean, this was blocked and up higher, so obviously the planet's on the move. And, well, it's moving that way. We know that much anyway. And here it is again on the Go 16 East. Same deal on the 17th. When I caught it, the pixelations were way up here. So it's obviously changed positions. Time-wise, I think it's about the same, I suppose. So here's the universal time in Australia. It's 11 hours ahead of UTC. So this, yeah, add 11 hours to that, so that would make it 11. Starts showing up around 10:50. Starting to see some light there in the picture. Gets right over opposite of Melbourne around 11:10 or 11:20. So that's that there. Here's ISWA. Now those weather satellites I showed you, the Go 16 East, it's up here in geosynchronous orbit. And I think it's pretty much a stationary geosynchronous orbit because it's always facing the east side of the planet. Hence it goes 16 East. And then the Himawari-8, it's always facing the western side of the planet, or vice versa. And they're both in this geosynchronous orbit of 22,236 miles, plus or minus 5 miles. So whatever the object is that came into view, I caught it on the 17th. It may have been showing up sooner than that, is somewhere right close to the 22,236 mile orbit. And I would say that since it's moved, was showing up higher. So I'd say it's moving, it's coming in. I would say it's coming in toward the planet. I mean, why not? I mean, we've seen a lot of objects in the sky in different photos over the last several years, and they're still showing up on the FAA webcams in Alaska. You're still getting a few guys putting out videos on that. Nibiru Action being the one. Just about the only one, really, that I know of. He just posted a couple yesterday on the Alaska FAA webcams. So anyway, here's the geosynchronous orbit. This is all on the ISWA site. International Space Weather, I think it stands for, or something like that. And these goes in 1314. You see them represented here. I believe these are what's collecting all this data, these satellites, and then they're generating these computer models. This is the Z-cut. This is looking straight down on the planet. So pretend you're a drone or a spacecraft and you're sitting right above the Earth looking down from the North Pole. This is what you would, this is the view that they're giving you on the Z-cut. These are the solar wind arrows. The sun's on this side. See the light side of the Earth. This here is just, I don't know why they have that disk on there, but this is the actual Earth size right here. And so you see the solar wind arrows, and there's the solar wind speed. Now I mentioned yesterday that I forgot what the epiphany was back on 9/29 when I was showing you, or 9/27 when I was showing you that video showing you the gap on ACE of 9 hours. And I remember now, since that was on a video about solar wind speed, it was up for over 1,300 kilometers per second, which the normal's between 400 and 700. The epiphany was that the solar wind speed, it was being measured inside the purview of these GOES 6, 13, and 14 satellites, and not the ACE and Discover satellites, which are way out there at the L1 Lagrange point. So this is the L1 Lagrange point. ACE and Discover are both parked out here. So is the SOHO spacecraft, where you get a lot of shots of the sun. And the last GOES C2 and C3 images come from around here. I was reading up on it. Apparently the SOHO anyway, it orbits around in this L1 Lagrange point area. So it gets different views. That's why you see that that sun spacecraft a lot of times, that winged object up near the sun. I've seen this theoretically. This guy's. This is a good link. I'll put it in the description box. This is talking all about the SOHO spacecraft around the L1 Lagrange point, and I'm sure you've seen these images, these cruisers up near the sun, on some of these last GOES C2 and C3 pictures. Well, this guy's got a pretty good theory of what they are, but anyway, he explains how it rotates around. It orbits at the L1 point, so sometimes it gets different views. That's why they're saying it can see around the corners. And in his final synopsis was that NASA or somebody has a spacecraft parked out here at the L3 Lagrange point, and when this SOHO thing's orbiting around this L1 point, every now and then it gets a good clear shot at the L3 Lagrange point, and then that thing shows up, that sun cruiser with the wings. But I'll put the link. It's pretty cool. Or he thinks it's from another civilization, and that would be the perfect Stargate point. He favors the Stargate fantasy. First perfect place to put a visiting craft to monitor any inhabited planet without scaring the natives. So it's interesting, but I mean, it gives you some good ability to picture what's going on out there in space with these different satellites and so forth. So getting back to here, and I'm already past 10 minutes. I'm sorry. So all this stuff being measured in here is coming from these satellites in here, not from out here at the L1 point where ACE and Discover are parked. I pulled up the latest tracking plots for ACE, and we've only had a couple of gaps in the last day, which you can see here. See at the 22 and the 1900 hours. So there's those objects that passed ACE are still creating some kind of data blockage from ACE sending the data to the Earth tracking stations. Discover, on the other hand, has had no such trouble. It's getting its data downloaded to the Earth tracking stations without any problem. Here's the last 24 hours on Discover. You don't see any gaps. You didn't see any gaps in the data entry. The phi angle is still mostly above 180, although it got down a little bit below there a few times. So we still have a strong interplanetary magnetic field connection with Nemesis, which is behind the Earth, or some solar body, whatever you want to call it, Hercolubus, Nemesis, making that field connection. The density numbers are still a little funky on ACE versus Discover, and you're still getting the splashed out effect. So I'm still sticking with my theory about that being the magnetosphere from the large planet, the 9-hour gap planet that passed ACE and hindered Discover's data download for a day or so, which passed both now, is still disturbing this magnetic field inside the purview of ACE. So let that play through for a minute. There's really no missing time. I checked it all out. And the solar wind speeds didn't get too crazy. I saw it go up around 700, 800, I think, a couple of times. But that's, keep in mind, that's all within here. See these solar wind numbers? There's a 7 something. They're nowhere near that. See the solar wind? They have it dialed way down, 350 to 250. So there's nothing above, nothing even above 333. So there's no way that we're getting, these numbers are coming from the sun. Also, these density, these solar wind velocity spikes coming in, you see them. And look at all the interplanetary magnetic field lines, the blue ones getting all warped out. And look how many pile up in front of the planet. So there's some planets out here in front of the Earth, and at least one of them passed ACE, and it's on its way in. That's my contention. Pulled up these Enlil. This is a solar wind prediction. Now this is a prediction they put out. The radial velocity, they're predicting this from the sun. Solar wind speed, and I showed you on Discover, it's below 350. They have it projected out at around 400 to 500 plus for this run here. And the density, they got that pretty low compared to what the actual densities are. So my contention is that the solar wind pressure from Nemesis is piling up density in front of the Earth, and every now and then this big planet's magnetosphere helps to sling variable numbers at the magnetopods. You can see how it's shifting. I'm running out of time. God bless, peace, and I'm out.